Hello, welcome back. In this lesson, we're going to test out what we've written so far with regards to our GPIO driver. So, we've created these structures for our GPIO registers and our RCC registers. And we need the RCC because we need to enable clock access to our GPIO port. So, we're going to create an instance of this structure as well as this structure and then initialize our GPIO through the instance. So let's begin. Right, so I'm going to come over here and put a define statement to create the instance. I'm going to give it a simplified name. I'll say define RCC, and RCC is simply going to be a pointer to our RCC type def. So I'll say, let's say RCC, the name of the type def is this over here. Sorry, pointer over here. I should rephrase my sentence. So this RCC is going to be RCC. It's gonna be our RCC base address, which is over here. But we're going to typecast it to a pointer to our structure, RCC structure, right? So we've typecast this. We're going to say RCC base. Perhaps I should have written it like this. Whenever I'm doing typecasting, this is the way I write it. RCC over here because RCC base. So now whenever we want RCC base address, we can simply type RCC. We're giving a symbolic name to it. We're going to typecast this base address to a pointer to our RCC structure, because we've arranged our RCC structure to sort of correspond with, the base address and the offsets that represent the various registers. So I'm simply going to typecast this like this and say RCC underscore. This is the name of the structure type def. It's a pointer like this. Okay, we're going to do the same for GPIO. I'll say define GPIO A. We have GPIO A base. We can do for GPIO B and the others later. And GPIO A over here, this is going to be GPIO. It's going to be GPIO A base, and we're going to typecast this to the GPIO type structure like this. What makes this object oriented is we wouldn't need to create a new structure for B, C, and D. If I want GPIO B, I simply need to call GPIO B over here and typecast it to the same structure pointer. Right, but we'll do that later. So now we have RCC GPIO A. We can go ahead and blink our LED. We already saw how to blink the LED. We know the LED is connected to PA5, and in order to enable the LED, we need to enable clock access to the port that it is connected to, which is port A, and we need to configure its pin, which is pin 5, to an output pin. And pin 5 to configure to an output, we need to set bit number 10 in the mode register to 1 in order to configure pin number 5 to output. You can find this in the reference manual under mode register. If you read the part that talks about mode register, you find this. So I'm going to create symbolic names for these. I'll say define mode underscore 5 out, meaning configuring mode register. Mode 5, which is mode register bits that corresponds to bit 5. Configure it to output is simply shifting 1 to bit number 10 like this. Once that is done, I'm going to create another symbolic name here. I'll say define. This one I'll simply call it LED pin, and the LED pin is pin number 5. And to set it on, to set or to enable it, I simply want to enable bit 5. This is shifting 1 to position number 5 like this. Okay, once that is done, I can call my main function int main, and then void over here open and close, and then now I can call RCC over here, copy RCC. Because it's a pointer, I use the arrow operator. Use of undeclared. RCC base doesn't exist. We don't have the RCC base. This is interesting. I have a typo here, of course. Right. So now, when we use the arrow operator, we can call the AHP. We know our GPIO port is connected to AHP1. So I'll simply say AHP1 ENR enable register. And what we want to do is pass 1 there. I'm still getting these. What does it say? Member reference type unsigned int is not a pointer. Okay. Right, I suspect the reason for this is because we've not sort of surrounded it with brackets like this. This should solve the issue. As you can see, the error disappears. Okay, so by doing this, and I hope you understand why I'm writing 1 here, because if you go to the AHP1 enable register, actually let's just go there. I shouldn't assume you remember or know. I'm going to come over here, I'm going to go up here and Control F, and then I'm going to search AHP1 ENR for AHP1 enable register. I'll click here to jump there. As you can see, this the register is a 31-bit register. We use bit number 0 to enable clock access to GPIO port A. So if I write 1 over here to bit number 0, clock access is going to be enabled for port A. This is the AHP enable register, which is under RCC. Hence, I do RCC AHP enable register, and then I write 1. This is hexadecimal 1. If I expand this to binary, it becomes 0B 1 2 3 4, and then 1 2 3 1 like this. Right. And remember, this is the same as this. We can always delete the zeros in front of the number, but if we had zeros after, we couldn't delete those zeros. So it's the same thing. So over here it's 32 bits, so I can put all 32 bits or not. Right, so that's why I have this. So whenever you have a question or you have a doubt regarding a register, you can find it in the reference manual. That is why I'm trying to, get you used to dealing with the reference manual. Right, once that is done, we can go to the mode register and set the mode. So I'm gonna say GPIO A mode register, and I'm gonna say mode 5 set to output over here like this. Right, so this should initialize our GPIO PA5 for us. I'm going to open my infinite loop over here, open close, and then I'm going to say I'm just going to create a delay. I'm going to create a pseudo delay, so I'm going to say for int I equals 0, I is less than let's say 900,000, I plus plus. I'll just sort of run a few cycles doing nothing here, and I'll toggle the LED by doing GPIO A, and then I'll use this. I'll use the toggle operator, this one here. So I'll do GPIO A over here. We need the output data register to write an output to it. So GPIO A structure output data register, and then the toggle operator is to use this LED pin. So it's going to be setting this bit on and off, on and off. It's going to toggle this. I'm going to click over here to build. It's built successfully, no error. Click here to download onto my board. Yeah, I've not configured my debugger yet. Come to target options, debug. I'm using the SD-Link debugger. Come to utilities or settings, both fine. I think I selected the wrong one. You can see whether you've selected the right one from here. It's still telling me, okay, it's because I've not saved, so it's not changed. So I'll click settings over here and then reset and run. Okay, and then okay. Click here to download onto my board. And as you can see, my LED is toggling right. So it's working just like we expected. So this is part one of developing our GPIO driver. We've created the structures and we've given symbolic names to the various registers, and we've been able to test GPIO port A. In the next lesson, we shall include the other ports that we have available to us to this driver, and then we shall continue building on it until we are complete with the driver, and then we'll develop a library on top of the driver. After that, we'll build the whole thing from scratch in C++. So that's all there is for this lesson. If you have any questions, just let me know, and I shall see you in the next lesson. Also, if you're finding the course useful, kindly take some time off to leave a review. I'll appreciate that. I'll see you later.